What's up? What's up? Going to get this video started. We're going over exam 1, question 1. And, well, I should say section 1, actually. It's not question, it's section 1. And I drew the provided graphs here. Today we're going over limits on this question. And we're going to use these provided graphs to find the value. And it says right here, if a value does not exist, we are going to explain why. And we can do that. So our first limit is actually limit of f of x as x approaches 1. And when we are finding limits, a limit means is asking what value is a function approaching. What is it approaching? And for a limit to exist, for example, on this one, as x approaches 1 of f of x, so it's going to be this graph, it has to reach the same limit from both sides. So let's take a look at f of x at x equals 1, as x approaches 1. Which is right here. The value is 1, -3. So as you can see, the line is approaching -3 from the left side, and it's approaching -3 from the right. So let's put this in limit notation. First, we're going to look at it from the left, and we're going to put a little negative to say that we're looking at it from the left. And it is approaching -3, equals -3. And now we're going to look at the limit of f of x as it approaches 1 from the right. So we're going to use a plus sign. Is -3. Look at that. So we can go ahead and say that the limit of f of x as x approaches 1 is equal to -3. There we go. But we're not done just yet. Our next limit is the limit of f of x as x approaches 3. So let's look at 3. 1, 2, 3. We are at 1, 3, 1. So let's just split this up. The limit of f of x as x approaches 3 from the left is equal to, it is approaching 1. And notice that this is an open circle, meaning the line is approaching the point, but it actually isn't touching the point. It's getting just as close as possible to 1, but it's actually never going to touch that point because it is an open circle. That point does not exist. Now let's look at it from the right. If you look at it from the right, it's actually disconnected, and we have what is called a jump discontinuity. As you can see, it kind of jumps and it starts somewhere else. And we actually have a filled in circle right here, which tells us that from the right, it actually does touch that point. That point being -2. But we have a bit of a problem. It does not approach the same value. So what do we do about this? The limit does not exist. And why does it not exist? So and this is because it doesn't approach the same number. It doesn't approach the same value, meaning if you were to try to figure out what the function approaches at x equal to 3, you don't have a value. You don't have a limit. We can't say that this limit is continuous. And that is because, again, have a jump discontinuity. We have a jump discontinuity. So that's okay. Not all the functions are gonna have, real limits. So let's look at the next one. We have the limit of f of x as x approaches 6. We're gonna look at it from the left first. And look at that. So, as you can see, it is approaching 1 from the left. Let's look at it from the right. From the right, it is approaching 1 as well. And you may see that it is an open hole right at x is equal to 6. Just because there's a hole, the point doesn't exist, it doesn't mean the limit doesn't exist. It is approaching the same value, and that is all that we're worried about for this question particularly. So it is okay, perfectly okay, to say that the limit of f of x as x approaches 6 is 1. Very nice. Good work, everyone. Let's look at the next limit. And next up, we have the limit of f of x as x approaches 10. As x approaches 10. So, let's look at it from the left. The limit of f of x as x approaches 10 from the left is approaching 1. It's approaching 1. So now let's look at it from the right. And you will notice that from the right, it is at 10. Or I mean, it's at 1. At x equals 10. So the limit as it approaches 10 from the right is just 1. And now we can say that the limit as x approaches, limit of f of x as x approaches 10 is 1. Because they approach the same value as they approach 10. So next up, we have the limit of g of x as x approaches 4. Now let's look at g of x. It's this graph. As it approaches 4, we are right here. So let's look at it from the left. Whoops. Not f of x. We're looking at g of x, actually. And from the left, just a straight line, it is approaching 2. The value 2 on x equals 4. Now, we have to look at it from the right. We've got another straight line, but it is approaching 2. So we know that limit of g of x as x approaches 4 is just 2. I think we can fit one more on this side. And our next limit is the limit of g of x as x approaches 6 from the left, and it's just asking from the left. We don't have to check the right side in this case. So let's look at it from the left as it approaches 6. It is approaching the value 2, and there is an asymptote here. No line will ever cross this asymptote. There's no way that we can even plug in the value 6 into this. It just simply doesn't exist. No point will ever exist on this function for x is equal to 6. So it's just asking for the left. So we can go ahead and just say that the limit as x approaches 6 from the left is 2 again. It's just a straight line. It's still on 2. So we are done with that one. We have our next limit of g of x as x approaches 6 from the right. So we just looked at it from the left. Now let's look at it from the right. We have an asymptote. From the right, it is approaching the asymptote and it goes down. And just to show you, it is going straight down and it's never going to hit this line. It's going to get as close as possible, but it is never going to touch the line. So as you can see, it's going downward. So when we look at it from the right, we can say that the limit of g of x as x approaches 6 from the right is negative infinity. It's going to be infinitely big in the negative direction. So let's look at our next limit. And this one is asking the limit of f of x plus g of x as x approaches 3 from the left. And the limit property tells us that we can really just find the limit of f of x as x approaches 3 from the left, and just add that to the limit of g of x as x approaches 3 from the left. So let's take a look at our graph. F of x at 3 approaching from the left, negative 3, or my bad, just 3 from the left. It is approaching 1. So this is equal to 1. And let's look at g of x as it approaches 3 from the left. It is approaching, as you can see, negative 1. So it is 1 plus negative 1, otherwise just 1 minus 1, which is equal to 0. The limit is equal to 0. And that is our answer. Let's look at the next one. We're going to look at it from the other side, of course. Limit of f of x plus g of x as x approaches 3 from the right this time. So we can use the same property of limit function to just find f of x first and then find g of x. So the limit of f of x as x approaches 3 from the right, and look at our graph, and that is -2. Is equal to -2 plus, now let's look at g of x at 3 from the right. 3 from the right, we have a straight line, and it is at 2. It's at 2. So would you look at that? Our value is 0 again. Whoop. I kind of struggled to draw straight lines. And it is graph paper and all, but we're just going to pretend that didn't happen. Our next limit is now sort of putting it together, if you will. The limit of f of x plus g of x as x approaches 3. So we have to determine what this really means. So, as you can see, we've checked the limit from both sides already, and they equal the same thing. In this case, we already know that the limit of f of x plus g of x over x approaching 3 from the left is equal to 0. We know that the limit of f of x plus g of x as x approaches from the right is also equal to 0. So we can use this gathered knowledge and we know that they approach the same value. So the limit of f of x plus g of x as x approaches 3 is equal to 0. And that is because we have our properties of the limit. Next limit, let's take a look. We have the limit as x approaches 0 from the right. And this is something we haven't seen before. Limit of f of x, whoops, messed up again. Limit of f of x times g of x. So we can rewrite this again with the same sort of properties that we're using for limits. This is the same as limit of f of x as x approaches 0 from the right times the limit of g of x as x approaches 0 from the right. So let's find our values. Let's find our limit of f of x as x approaches 0 from the right first. So f of x approaching from the right, as you can see, looking at it from the right, it is approaching -1. So the limit is -1. Now let's look at the limit of, limit of g of x as x approaches 0 from the right. What is it? 5. So now we can kind of just multiply these values since we have them now. We know what they are. It is -5, so we can say that the limit of f of x times g of x, x approaching 0 from the right, is equal to -5. Very good. Now, let's look at the next one. We have the limit of f of g of x as x approaches 5. So it's getting pretty interesting. Now, f of g of x, we have an inside function. That means we have to find the inside function first to then know what we find for the f of x. So we plug our 5 into the g function. Let's look at it. What might the limit be? So g of 5 is at 2. Approaching from the left is 2. Approaching from the right is also 2. So I'm not going to write this one down, but we know that, whoops, just going to separate the limit of g of x as x approaches 5 is equal to 2. So now we have to find the limit of f of 2. I'm filming like a video. I think there's like another study room somewhere. Sorry about that. So we find our limit of f of 2 because we just found our value, which we can plug into our f function now. Whoops. We just have to find our f of 2, which is equal to, let's take a look. F of 2 is -1. So now we can put this all together, and we know that the limit of f of g of x as x approaches 5 is equal to -1. Sorry for the interruption. And we're moving on to our last limit now. There's actually a bonus limit as well, so not sure if I even have to cover this one, but why not? Our next limit is the limit of f of x as x approaches 3 from the left. So let's take a look at our f of x as x approaches 3 from the left. We know that our limit is 1. So we're going to plug that in. Our limit of f of x as x approaches 3 from the left is equal to 1. And now we're going to plug this value into our g function. Now we just check that out. G of 1 is just 3. Yes, 3. So let's put it all together. The limit of g of f of x as x approaches 3 from the left is equal to 3. And that is how you evaluate limits.